Okay, so question for Elena about two satellites colliding. The good news with this one is that the answer is relatively simple, but I'm going to use this video and a couple of little props here to explain it a little bit more in depth to help you answer future questions like this. So, first thing, the answer is it's the same. And this is a little bit of a red herring question that you might get from time to time because they do give you initial velocity, they do give you some masses, even though from what you typed, I didn't see any specific units for those. It could be in kilograms, tons, pounds, whatever. But none of that matters. The answer is the relative velocity will be the same before and after. The short answer for why that is because momentum is conserved and this is an elastic collision. In elastic collisions, momentum and energy are conserved, so all of the momentum before had to be the same as all the momentum after. So what does that mean in practice and how does that apply to this question? So first thing, relative velocity. Relative meaning we're comparing both objects. So in reality, right, we have these two objects heading towards each other, and they're both probably moving towards one another, which means they both have their own initial speeds, which we don't know, but they're both moving towards each other. In some sense, they're moving, and if you were to imagine, relative means that we can actually think about one object as being perfectly stationary relative to the other one. So you can imagine one of the satellites is perfectly still and the other one is moving towards the first satellite with the initial velocity that was given to, which I think was like 2.1 meters per second, 0.21 meters per second, whatever it happens to be. But for this problem, that's what they gave you, right? So 0.21 meters per second, one object is moving with that velocity. It has a given mass, which means it'll have momentum, mass times velocity. And then the other object, the first satellite, in this scenario would have a momentum of 0. Then they collide, and because it's an elastic collision, they bounce off each other. Now, this first satellite has a little bit of momentum because it bounced off of the other one. Now it's going to start moving away in this direction with whatever velocity it has. And then the second satellite's going to move away a little bit slower with a little bit less momentum because it gave up some of that momentum to the first satellite. But the total momentum is going to be the same regardless because momentum, again, is conserved. So we don't need to know the numbers associated with any of these. We need to know the values of any of these terms. Just knowing that momentum is conserved tells us that the relative velocity will be the same both times. So in this case, since we know that they're going to bounce off of each other, but they're both moving towards each other initially, it'll probably be something sort of like if their relative velocity will be the same. So it's as if one object is still stationary and the other one is moving away with a 0.21 meter per second velocity, just in the opposite direction. So the magnitude would be the same, just inverted because the direction is opposite. So same speed, different velocity because the vectors would be opposite, going in the other way. So that's all you need for this question. Look out for problems like this. You might see, like I said earlier, problems where they give you a whole bunch of information, but really it's a conceptual question, and they're just testing you to see if you understand the ideas behind something like conservation. Classic examples be energy, momentum, angular momentum. All those things are conserved. So keep an eye out for those. Don't be initially fooled. If you can't think of an easy equation to answer the problem, then likely it's a conceptual one and it doesn't need any math whatsoever. So hope that helps. If you have any other questions, leave a comment down below. And best of luck with the rest of your work. Take care.